So hello guys, here we are trying to make a game. So basically the idea of the game is we are gonna make a 3D game, 3D maze game, and then we are gonna train our reinforcement learning model in that environment. So I'm just gonna go over my code. So if you guys wanna like learn in detail about all of these things, shaders, libraries, vertices, you can comment down below, then I can like explain everything in detail. But this is just an overview. So we got our shaders over here, vertex shader, we got fragment shader. Vertex shader runs for each of these vertices, and then fragment, and this is gonna, vertex shader is gonna create a skeleton, and then fragment shader is gonna paint every pixel in that skeleton with a color. Right now we are using red color, and then this is a cube, vertices for a cube, and this is a code for my mouse movement inside the game. And then here we are creating a window by asking operating system. GLFW is a library that is used to ask operating system for a window on the screen. And and then here we are compiling our shaders, and then we are sending it to GPU, and we are linking them together. So GPU has one executable shader program, and here we are creating our buffers, and over here we have depth test. So basically what it makes sure is that if the two faces of a cubes are in a straight line, it's gonna show the one that is above the other one. So depth test just make sure about that. And then this code is, we are basically calling our mouse movement function. So you might be asking, why are not we putting it inside the while loop? Because in uh, while loop is the thing where everything renders on a screen, right? So basically we are setting it. It's just a callback. It means that every time I move my mouse, operating system is gonna automatically calculate the position, because we are over here poll events, or so it makes sure that operating system, every time operating system calculates the uh, position of my mouse, and it's gonna automatically call our mouse movement function. Then here is our main loop. We are basically clearing the screen with this black color. So basically it just means that, as we know that there are two buffers inside the GPU. There is back buffer, and then the front buffer. So back buffer is where first operating system draws our picture, and then it gives it to the front buffer, which actually shows it on the screen. So we are clearing those buffers with a black color. And then what we have, okay, this is the MVP code. So basically what it does is this is a code that shows how our 3D object is gonna appear in a 2D screen, so we can see it as 3D. So this, where is it? Yeah, right here. Yeah. So basically, we are multiplying projection, which is this view. So what does view means? View is um, basically the how to say it? Vertex. No, vector. Yeah, sorry. So view is basically the vector for the camera. It's gonna control the camera position. Projection basically shows us that how, if our object is far away, how we are gonna show it on the screen. If it's near, then obviously it's gonna be zoomed in. So that's how are we gonna show that object. Projection makes sure about that. Model basically just tells the graphic card that where in the screen our model should appear. So like right now this basically means 1.1, when translate basically means that 1.0 f, it's gonna, our cube is gonna appear at the origin. So basically origin is this is the position for the origin. It's gonna get appear in that position. Then we are translating it little further by multiplying it with these numbers. All right. So we are multiplying all of these things over here. Then we are giving this to the shader, because shader is expecting it. Then this is the main code. This is going to draw everything. And then we are swapping buffers over here, and over here we have the code. We have the code for our keyboard movement. Now I'm gonna run my code and you can actually see it. Because I'm using 3 for loops to adjust the model's position. So basically, as we can see, we are not adjusting camera position, we are not adjusting far or near position because it's gonna be similar for everything. We are just adjusting that where in this world our model is gonna appear. So we are just concerned with that. So again, we are first getting the model at the origin, then we are changing its position to move it a little further. And yeah, I think that's it. If you guys want to like learn it in detail, I can like make another video. And plus also what I want to do is basically I want to implement a backtracking algorithm to generate a complex maze, so we can like actually explore something, and then we are going to like implement our physics so we cannot move inside the boxes or cubes. Yeah, thanks so much.